Consider figure 1, where A, B, C are vertices of triangle ABC. So let's determine the gradient of line AB. Okay, so we need a formula to determine the gradient. So the formula goes like, so let's just say M of AB. So M is just saying the gradient of AB is equals to change in Y over change in X. Okay, so or we can express it as y2 minus y1 over x2 minus x1. So to find the gradient of a line, we need 2 points or 2 coordinates along the line AB. So in this case, we have A and B. So we just have to decide which should be our x1, y1 coordinate and which should be our x2, y2 coordinate. Okay, so now it's just a matter of substituting correctly and determining the gradient. Alright, so our y2 is -6, then we say negative our y1, which is -2. Then we say divided by our x2, which is -1, then minus our x1, which is -5. Great. So include these terms in brackets because this negative actually affects our terms. Right? As you will see, this just serves as -6 plus 2 over a -1 plus 5. Alright, so this will leave us with a -4 and a 4, which will give us -1 as our gradient. So let's determine the length of line AB in the simplest SAT form. Alright, so we will use this formula to determine the distance between A and B. So this will be our x1, y1 coordinate, this will be our x2, y2 coordinate. Alright, so now it's just a matter of substituting. So D just noting that is the distance between these 2 points. So our x2 is -1, and our x1 is -5. So we put it in brackets, then we say plus our y2 is -6, then minus our y1 is -2, then we square. Alright, so now let's simplify. So we're going to get a positive 5. So we get a -1 plus 5. So this is just going to give us a 4, right? Positive 4. So let's square it, then plus. Then we have a -6. Then minus and minus will give us a positive 2. So if we simplify this, which will give us a -4, then we square it. Alright. So if we square, our terms will be left with 16. That's 16, which will give us a root of 32. But in the question, we were asked to leave our solution in the simplest SAT form, which means it's possible to simplify this a bit. So let's do that. So 32 is just the same as 2 times 16. All right. And using principles of SAT laws, or using SAT laws, I mean, it's just the same as √2 times √16. We just separated it, and this is √16 will give us a 4, and √2 just remain as √2. So this is the simplified solution. So moving on to question 4.3, we need the coordinates of the midpoint of the line segment BC. So a midpoint is just a coordinate between B and C. So let's just place it along here. And let's just call that point P. Okay, so we need to find its coordinate. So we have to use this formula. So now just a matter of determining which should be our x1, y1 coordinate and our x2, y2 coordinate. Okay, so now let's determine our P. So our x1 is -1, our x2 is 5. Then we divide it by 2, we do the same. Our y1 is -6 and our y2 is 4. Then divide by 2. Alright. Now let's evaluate. We get a positive 4 divided by 2. and here we get a -2 divided by 2. So this is going to give us a coordinate of 2 and -1. Okay, so we need now to determine the equation of the line segment in the form y is equals to mx plus c parallel to the line BC and passing through the point A. So let's highlight that line on our diagram. Alright, so this is the line which we need to determine its equation parallel to BC and passing through point A. So to calculate the equation of a line, we'll use this formula. So we need a gradient and a point to determine the equation of a line. So since it's passing through the point A, we use A as our point. So a point should be along that line. And now concerning the gradient, since we are given that this line is parallel to this line, it implies that BC is the same gradient as this line. But we haven't yet calculated the gradient of the line BC. But let's determine it because we already have the values B and C. Okay, so this will be our x1, y1, and this will be our x2, y2 coordinate. So now let's substitute correctly. Our y2 is 4, our y1 is -6, and our x2 is 5, and our x1 is -1. Alright, so this will give us a 4 plus 6 over a 5 plus 1. So our gradient is going to be 10 over 6. If we divide everything by 2, we get a 5 over 3. So this is the gradient of the line BC as well as this line which we need to determine its equation. So this gradient is 5 over 3. So now let's solve for its equation. Okay, so we have y minus our y1 is -2 is equals to 5 over 3. Then in brackets x minus our x1 which is -5. Alright, before we proceed, let's evaluate this part. Negative and negative multiplied to give us a positive value. So I'm just going to put a positive here. Alright, now let's simplify our equation. So we get here, we're also going to get a positive as well if we multiply a negative with a negative. Alright, now we have y. Because we need to place like terms together, and because we also have to leave our equation in this form, which implies that these two we have to go on the other side of the equation. So we have, if we multiply, if we expand the bracket, we have a 5x over 3, then plus 25 over 3, then obviously a -2. -2 is just the same as 6 over 3, because we want to make this a single fraction. So this will leave us with a solution of 90 over 3, which is our solution. So we need the angle of inclination, which is between BC and the x-axis. So let's highlight that angle. So this angle is an acute angle. So let's use this formula to determine it. So theta is equal to arctan the gradient of the line which is inclining on the x-axis, which is BC, which means our gradient will be the gradient of BC. Alright, and the gradient of BC is 5 over 3, so we just have to substitute that value. So tan inverse 5 over 3, and to get a solution, simply have to punch tan second function tan, then 5 over 3, and to get 59.036 degrees. In case you are wondering, where are we getting this formula and why are we applying in this manner? Okay, let's say we have something like this, and we have theta, and let's just call this change in y because it's along the y-axis. This change in x from here to the here. If you apply trigonometrical ratios, we can say tan theta is equals to change in y over change in x, which is change in y over change in x, just gradient, right? Which implies that tan theta is equals to m, therefore theta is equals to tan inverse of m. So this gradient comes from this line, and we applied it this way. So let's move on to question 4.6, where we need the equation of the line segment in the form y is equal to mx plus c perpendicular to the line BC and through the midpoint of BC. So let's highlight that line on our diagram. So it's perpendicular to BC and passing through the midpoint of BC, which is 2 and negative 1. Okay, so let's determine this equation in this straight form. So the formula which we'll use is as follows, which means we'll need the gradient and a point x1, y1. So the gradient of this line is determined using this formula. Okay, and the point, we can take any point which is along this line. In this case, we'll take the point P, which we already determined, which was 2 and negative 1. Okay, so now let's calculate the gradient of this line using this given formula. So when we have perpendicular lines, the product of their gradients is equals to negative 1. So the gradient of BC, we have it. So which means this equation, we model it as the gradient of line BC applied with the line passing through P. Its gradient, it should give us a negative 1, right? Which means the gradient of that line will be negative 1 over the gradient of the line BC. Okay, so now let's substitute the gradient of line BC, which is 5 over 3. And this is going to give us a negative 3 over 5. Alright, now that we have the gradient, we can actually determine the equation. Okay, so we have y minus the point. The y value is negative 1, which is equals to, and m. The gradient is negative 3 over 5, then x minus the x value, which is 2. Alright, so we have y plus 1 is equals to, if we expand the brackets, we have negative 3x over 5, then a plus 6 over 5. Okay, so then we place like terms together, we get a negative 3x over 5, then plus 6 over 5, then minus 1. Minus 1 is just the same as 5 over 5. Alright, then this will leave us with a 1 over 5. And as the question said, we should leave this solution in the form y is equal to mx plus c. So we have solved the problem.